Hello everyone, this is our second class for pre-calculus. Our topic today is exponential, logistic, and logarithmic functions. First, what is an exponential function? The form of exponential function is f(x) equals to a times b to the power of x, where a is non-zero, b is positive, and b is not 1. And a is the constant a is the initial value, and b is the base. For example, f(x) equals to 2 to the power of x is an exponential function. When x is 4, f(x) is 2 to the power of 4, which is 16. When x is 1/2, f(x) is 2 to the power of 1/2, which is square root of 2, and approximately equals to 1.4. There are two kinds of exponential functions that are growth and decay function. When a is greater than 0 and b is greater than 1, it's a growth function, and the graph is like this. And when a is greater than 1, b is smaller than a is greater than 0, b is smaller than 1. It's a decay function. The graph is like this. In growth function, greater base leads to be steeper. For example, if this is 2 to the power of x, this is 3 to the power of x. And in decay function, smaller base leads to be steeper because bases are functions. For example, if this is 1/2 to the power of x, this is 1/4 to the power of x. The next is logistic function. This time we only focus on logistic growth function. The form of logistic growth function is f(x) equals to c over 1 plus a times b to the power of x, or f(x) equals to c over 1 plus a times e to the power of minus kx. And in this function, where a, b, c, and k are all positive, and b is smaller than 1. This is a bounded function. The domain of the function is negative infinite to infinite. The range is from 0 to c. This is because we can solve from this by using limits. When x approaches to infinite, this term is a fraction that approaches to 0. Because this is 0, so the denominator is just 1. So limit f(x) is just c. And when x approaches to negative infinite, the denominator is so large that the whole fraction is just 0. So limit f(x) is just 0, so we can obtain the domain. Also, the asymptotes are y equals to 0 and y equals to c. To obtain the y-intercept, we make x equal to 0. Then b to the power of x is 1. So the y-intercept is 0, c over 1 plus a. Now we can draw the graph, which is like this. This is y equals to c, and this is 0. The last one is logarithmic function. It is the inverse function of exponential function. In exponential function, y equals to b to the power of x. However, in the logarithmic function, the dependent variable is x, so it should be x equals to b to the power of y. It can be written as y equals to log base b of x. For example, to solve log base b of 8, b is 2 and x is 8, so y is 3, because 2 to the power of 3 is 8. Another example is that log base b of 1 is 0, because 4 to the power of 0 is 1. This logarithmic is the inverse of exponential, so the graph is also inverse. If exponential is growth, the graph of logarithmic is also growth. So the growth exponential is like this, and to draw the inverse is this. If the exponential is decay, the graph of logarithmic is also decay. It is the same as the growth. The decay exponential is this, and to draw the inverse is like this. And at last, there are 3 important rules of logarithmic function. The first one is product rule. The product rule is log base b of rs is equals to log base b of r plus log base b of s. In this case, b is greater than 0, r is also greater than 0, and s is also greater than 0, and b is not 1. C is any real number. The product rule is because we can make m and n to be real number, and let m equals to log base b r and n equals to log base b of s. In this case, because m is equals to log b of r, so b to the power of m is r, and in the same way, b to the power of n is s. So Bm times Bn is Rs, and b to the power of m plus n is Rs. So log base b of Rs is equals to m plus n, and also equals to log base b r plus log base b s, because m is this and n is this. The second important rule is power rule. Power rule is log base b of r to the power of c is equals to c times log base b of r. This is because log base b of r to the power of c is equals to log base b of r times r times r times blah 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 times r, and there is c terms. And this is also equals to log base b of r plus log base b of r plus blah 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 plus log base b of r, and there's also c terms. In this way, we can obtain this is equals to c times log base b of r. And the last one is quotient rule. Quotient rule is log base b of r over s is equals to log base b of r minus log base b of s. This is because log base b of r minus r over s is equals to log base b of r times s inverse, and this is equals to log base b of r times plus log base b of s to the power of minus 1. But this is using the product rule. So now we can obtain log base b of r minus log base b of s.